Hey, what's up? Welcome back to another very exciting tutorial. Today, we will build a laser system and use it to precisely cut out a camera packaging. I will show you a cool technique that allows you to use any product. It doesn't have to be a camera, it could be an apple, a tennis racket, it could be even a car, whatever you want. So, without further ado, let's get started. Okay, first we go into the asset browser and look for the digital camera. Double click and we bring it into our workspace. Let's zoom in and take a look at the camera. And also we are using redshift as the renderer. We are not going to worry about the individual materials. There are standard materials, but we don't worry about standard or redshift. The most important thing is that we build a camera skin from the camera body itself. Therefore, we are copying the camera body, and we don't want to include the branding. So we delete the brand because it should be revealed from the laser itself. And when we have done that, we are connecting all and delete the camera body itself. So now we have a skin from the whole camera body. And this is an important step where we can continue to work. So we have a camera skin, and let's rename the camera body as the camera skin. We want the geometry of the object to be uniform. This is not a problem with this object. The geometry is even, but maybe you are working on an object that has no quads. For this purpose, we will recreate the object and put it into a volume builder. In the volume builder, we set the voxel size to a very small number, 0.02, and put the whole volume builder object into a volume measure. And in the volume measure, in the object properties, we use the absolute value ISO checkbox enabled and leave anything on default. And when we hit on the keyboard NB, so we can see the mesh density and the geometry. This looks good, and you can see it's a very tiny and even geometry. This is the right format we are searching for. And let's do a little bit of housekeeping. We are putting the whole mesh object into a null, which we rename it as a backup. And then we connect the objects and delete. So we have the whole volume measure. And yeah, it looks good. We can take the next step. And when we include the original camera, then we see that the whole objects are slightly overlapping itself. That's exactly what we want. The next step is to put the whole volume measure into a closed surface object, because we want a little bit thickness of it. We delete the subdivisions and give a little bit tiny thickness, 0.01 centimeters. So the whole camera skin has a thickness on it. And the next step is we putting the whole object in our null, in our backup object, so we can do a little bit modifications and do not overwrite our object itself. And the next step is building the animation where we can reveal our camera skin with the laser. We are integrating a plane effector and a polyFX effector. And the polyFX effector is underneath our volume measure and our camera skin. And in the polyfix effector, we are integrating the plane effector. So, and right now you can see that the whole skin is gone because we changing the position, the rotation, the scale. In our case, we are scaling it down to 0, 1. That means everything is gone. The whole structure is gone. Therefore, we have to include a linear field into the plane effector. And the linear field is way too big, so we have to scale it down, going into the coordinates and put it to 0.4 on every axis, maybe also too big, 0.2, and from there we can do smaller changes, adapt the linear field as it should be on the size. Let's zoom into our camera body and put the field into the plane effector. And right now you can see that the field is doing exactly what we want, but we have to modify the linear field because the laser is very tiny, very thin. And so we have to remap the linear field. We are going into the inner offset and change it from 0 to 98. And now you can see you have a very small line from the linear field, and that is exactly what we want. We are changing the size of the linear field, and now you can see it's working perfectly. All right, with this setup, we can modify the plane effector. Maybe you can change the position. Let's see, when we change the position or the rotation or position and rotation, you have a complete different setup. So you have the possibility not only to create a laser effect, but you can also do a complete other effect, like a product reveal, where the product itself is building up on its own. So the limits of the imagination are unlimited. So for instance, when we change the inner offset of the field, of the linear field, and we have a position and rotation update of the particles itself, let's say particles, then we get a complete other effect, and looks also very cool. So for another product reveal maybe, let's go back to our laser effect, what we want to do, and therefore we change the rotation and the position. So we disable the position and rotation of the plane effector, and we are concentrating just of the uniform scale and change back the inner offset to 98%, where we have a very tiny small gap of the camera skin, and there we will include the laser. Perfect. Looks very promising from my point of view. And the next step is to integrate the laser. But before we are integrating the laser effect, we are opening up the redshift renderer. Therefore, I have a workspace where you can see the redshift render on top, on the left top side. And let's do the rendering. And right now you can see the camera skin itself without any material. But the most important thing you can see is that there is a skin over the camera, which we can change using the plane effector and a linear field. And this skin has a certain thickness. This is the most important thing. Okay, let's concentrate to integrate the laser. The laser itself is, it's a cool trick. The laser itself is just a cube, a very small cube. So we integrate a cube and change the position and the scale so that the cube itself is a very tiny, small, let's say, yeah, a brick. And just position it on the beginning of the skin. So it's a little bit tricky to get the right position and the right scale. Okay, from the first point it looks promising. So let's change the scale again and the position. Therefore, we are going into the top right front view so that we have more or less a perfect viewing angle. Okay. And the next step is to integrate the cube itself into the plane effector and group the field with the cube into a null object. Because this is an important step when we are animating the whole thing, that the linear field is repositioned together with the laser. So we have only to concentrate about the null object itself, and the laser is doing the right thing together with the linear field. So you can see when we just move the position of the null object, the position of the linear field and the laser is changing together. This is a very important step. And now let's concentrate about the laser and the material on it. So therefore, we are creating a new standard material and call it laser, and put the new material on the cube, on the laser cube itself. And right now you can see in the render that the new material is rendered correctly. Now let's change the material. Therefore, it's just a standard material. We are integrating a new color node, and let's change the color to a very orange, reddish color, let's say. And we are integrating the color into the emission color. So there is a small bonus tip: with the control key and a click on the right circle and the right circle at emission color, you can forward the property to the outside and you do not have to search for it in the standard material. So it's just a small bonus tip, and it will help you a lot. And don't forget, it's not the left, it's the right circle where you have to click to. And there you have the color, and in the color itself we are putting in the color of the color node, and change the emission type, the weight of the emission to 20. And yeah, right now you can see the laser is working. Not so as we would like to have. Therefore, we are integrating a curvature map, curvature node into the opacity channel, change the mode to convex and set the radius, let's say to 0.1. Yeah, looks promising from my point of view, but we can see the whole brick and not the laser itself. That's not a problem. We make this invisible with a render tag. Since we will be using different modifiers and null objects to build up the laser system, it's not very easy to recreate this quickly. So you can download the entire project file for just $5, and you will find the link in the description below. If you like this tutorial, then please give me a thumbs up and leave a comment, and please subscribe to my channel. I would be very happy to stay in contact with you. So we add a new render tag, redshift object render tag, And there we override the visibility and change the primary ray visible to off. So we disable the primary ray visibility. And right now you can see that the laser is working. Maybe we adjust the radius of the convex in the laser material a little bit. Let's see from 0.1 to 0.17, and we are changing the laser, the thickness of the laser, the size of the laser. In this case, it's the size of the X value, just to give him a very tiny space from 0.025 centimeters or a little bit more. Well, it's a tasting of your personal preference. I personally like this. Maybe we can change the emissive of the laser itself. But before that, we are going into the settings of the render, and we are integrating the bloom effect. Let's see, just do the right bloom threshold and the softness a little bit and the intensity. And I personally think we should change the value of the emission type of the laser itself, just to boost it a little bit up. So therefore we are going into the laser, into the emission weight, and change the type from 20 to 40. And let's see. Yeah, the laser is more aggressive, let's say, more dominant, and I think it looks very promising from the first point. Yep. Yeah, the next step is to prove if it is working. So we are changing the position of the laser cutter. So the null object itself, as we have explained it before, when you change the null object, then the linear field and the laser itself is changing the position together. This is very important, so that when you have to animate it, you just have to animate the null object of the laser cutter itself. So the next thing is to prove if when we change the material of the camera skin, and how it does this looks like. And we have a very cool material in the redshift materials, and this is a very, very complex material. So when we integrate it into the camera skin and we open it into the redshift node editor, then you can see it is a very complex material. So let's open it, and there you can see that we have a very complex structure. We have different color nodes, different color layers, which are blended together in different materials, and different materials are blended together in a material blender, and this material blender is going into the output of the material itself. So it's a very complex material, but the thing is that we don't have any UV mapping. So this material allows us to have a triplanar, that's a very complex word, triplanar UV settings. And this is a very interesting thing, because you can, with this material and with the triplanar, so it's a very complex word, with the triplanar UV settings, you can delete the UVs, and you have a very, let's say, a good material for any object you want to integrate as a camera skin, as a skin of your object itself. So we integrate in this tutorial with this material, we integrate a redshift object tag and override the geometry, because the material itself has a displacement map on it. Change the displacement to a scale of 0.5, and the whole material and the complete size of the material is changeable via the triplanar size. In this case, we are choosing a size of 120 centimeters. Maybe it's too big or too small. It's just a taste you would like to have. Let's see if when we decrease it to 80, yeah, it looks much better from my point of view. Maybe 40, let's see. Well, it's a personal taste you would like to have, so just experiment with the whole thing. Maybe we integrate another material to test it out. Let's see, a blue metal paint coating. We integrate it from the asset browser and override the last material. And well, that's an interesting thing. I'm on the newest version of CGIMastery 25, and when you integrate another material on top of it, it doesn't render. You can reset the whole renderer. It doesn't matter. Maybe it's a bug. I found out that in this case, we are going into the laser cutter and change the position. And when we change the position of the material, then it's rendering again. So I personally think it's a small bug, but it doesn't matter because we have a workaround. Just change the null object and its position, and it's rendering perfectly. Wow! And right now, wow, I love this. You can see the laser itself with the convex of the in the opacity channel. It looks very promising from my point of view. Let's change the size of the redshift render preview and to see it a little bit better. Yeah, from my point of view, it looks very promising, and I think we can do the next step. The next step is to integrate a camera and doing the lighting setup. So yeah, it looks very promising from my point of view. So let's do the next step, the lighting setup. In this case, we are going to integrate a 3-point lighting because it's a product, and I personally tend to have a null object for the lighting setup. So I define a light null object, and every light itself is targeted to the light null object. When we add an area light, let's rename it as a key light, and in the key light we are integrating, we add a new animation tag, in this case a target tag, and in the target tag we integrate the light null object, so the light itself is always pointing towards the light null object. This is very handy, and I usually do my complete rendering, also the animation stuff, with this method where I have a key light, a rim light, a top light, and a fill light. If I change the lighting setup itself, I just have to change the null object, and every light is concentrating about the null object itself. Yeah, so maybe I can I can fast forward this process because I have a very detailed explanation in my first tutorial. You will find the link in the description below, and there you can see how I do the complete lighting setup with this method. So we will see it. We will see us together in the next 2 minutes. So I am back, and we have integrated a camera and have done the complete lighting setup. The next step is to integrate a backdrop. So we are going into the asset browser and integrate a backdrop. And let's see how the render is looking when we have integrated a backdrop. Maybe it's looking a little bit more pleasant when we have a small amount of let's see, wall against and a tiny floor of it. The backdrop also bounces the light back. So often I see that integrating a backdrop with the right material change the whole render itself in a much more pleasant way, let's say. So we have the right color of the backdrop and the right position and the scale of the backdrop. And now let's change the camera angle and the position itself of the camera. Let's play around with that. Maybe a little bit more rotation. Yep, okay, so that we can see the laser itself and the camera body itself. And yeah, and the next thing is to change the camera. Let's see, the redshift camera. In the optical tab, we change the depth of field. So we increase the bokeh and set the aperture, let's say, to 2, and change the focus distance so that we are in focus exactly where the laser and the camera lens zoom is placed, right there. Okay, yep. Maybe the aperture is a little bit too intense, so increase it to 5 or 4 point. Let's play it around 4.8. Okay. And the next problem, or let's say we have a workaround of this. It's also a bonus tip, what I often do, because we have a very tiny depth of field, and when we change the camera angle and when we change the focus of the laser itself, so the laser itself is changing, then we are running out of depth of field. So therefore, we are integrating a null object, and the null object itself, let's see, we rename the null object as the null focus point, and integrate the null focus point into the camera focus object. And then we are integrating the null focus into the null object of the laser cutter. So therefore, when we change the laser cutter, when we do an animation of the laser cutter itself, you remember, we just have to change the position of the laser cutter. The camera itself stays always in focus of the laser cutter itself. So this is a very cool technique. I always use this technique when I have to render an object with a very tiny depth of field. Okay, this is it, more or less. You can change the position of the camera angle. You can animate the whole thing. You can animate the laser cutter itself. And yeah, from my point of view, it looks very promising. And yeah, I find it a very cool technique to integrate such a laser cutter system with redshift. Let's make the redshift render preview a little bit bigger, resize the window, and now we can see it looks fantastic, really promising. I love this effect. There are endless possibilities to create cool animations and product reveals with this laser system. Thank you for watching. Again, if you like this tutorial, then please give me a thumbs up and leave a comment. And please subscribe to my channel. I would be very happy to stay in contact with you. And we will see you next time. Bye.